Welcome to Voice Bootcamp, a global name in unified communication. Hello, my name is Faisal Khan, CEO and founder of voicebootcamp.com. In this series of CCIE Collaboration Self-Study Kit version 2, I'm going to discuss about the SIP protocol. Now, the SIP protocol happens to be a session initiation protocol that resides on layer 7, which is an application layer, and it is based on an ASCII character. Now, because of the ASCII character, the SIP is one of the fastest protocols that exists. Now, it is used to establish, maintain, and terminate calls between the two endpoints. Now, the endpoint could be an IP phone, could be a hardware phone, software phone, a gateway, a black box device that supports various functionality related to call. Like, for example, it could be a fridge, it could be your car. These days, pretty much all of these devices are coming out with some sort of SIP enable component. Now, SIP was introduced by IETF, Internet Engineering Task Force, as an alternative protocol for multimedia conferencing. It was founded in March 1999, and it is compliant with RFC 2543 for SIP features. Now, Cisco's SIP implementation, which supported by pretty much most of the Cisco platform, it is used to signal the setup of voice and multimedia calls over an IP network. SIP is designed to address the function of signaling and session management within a packet IP telephony network. Now, signaling, which of course allows you to carry the call information across your network boundary, and it provides session management which has the ability to control the attribute of end-to-end call. Now, what is a SIP? SIP has many different components. You got the user agent, various SIP messages, which has a request and response messages. You got SIP headers, which can be modified, negotiation protocol to negotiate what their capabilities are. All these are part of SIP component. Now, so what do we use SIP for? Well, the capability of SIP will determine, for example, the location of a target endpoint. It has the ability to do address resolution, name mapping, and call redirection. It also has a capability to decide whether the call is a voice call or whether if a video is supported as well. So the media capability is negotiation also is part of SIP capability. It has the ability to find the target where it's located. It has the ability to establish a session between the originating and the target endpoint. One of the SIP capability is to handle transfer and termination of a call and provide conferencing between two or more parties. Now, SIP happens to be a peer-to-peer protocol as well as client-server. Now, when it's peer-to-peer protocol, each gateway or each device act on their own. That means phone 1 does not control phone 2, or gateway 1 does not control gateway 2, for example. Whereas in a client server, you got one device that is controlled by the other device. For example, if I have a software-based SIP phone where I enter my username and password and I click on register, it has to authenticate. So that is a client server environment. Whereas a peer-to-peer, I pick up my handset, I configure your IP address, I dial the number, call goes to your IP network, your device. As long as your IP network is up and running, then the rest of the responsibility is yours. So peer-to-peer, no authentication, whereas client-server authentication may be required. SIP, the devices in SIP session, or the peer, often known as, are often called as user agent. User agent can function in one of the following roles. You have user agent client, or UAC, which is an application that initiates the SIP request. So that would be like, for example, picking up the handset, dial a number. So you become the user agent client because you are the one that initiated the request. The server, on the other hand side, which will be acting as the user agent server, is an application that contacts the user when a SIP request is received, and that in return returns a response on behalf of the user. SIP endpoint is capable of functioning both client as well as server, depending on which direction the call is coming in. However, it functions as only one in a per transaction. Now, whether the SIP endpoint function as a user agent client or user agent server will depend on the user agent that initiated the request. From an architectural perspective, however, the physical component of SIP network can be grouped into two categories: a client, which is the endpoint, and the server, which could be the proxy servers. SIP client can act as either user agent or a server or user agent client. SIP client could be, for example, physical hard phone or a software-based phone on your laptop or your desktop. It could have some ePhone that are phone but not configured as a gateway, or it can also be acting as a gateway as well. So any gateway with the SIP enabled can be a client as well. Now, from a server perspective, there are a few servers that we need to go through. You got SIP proxy server. In an environment, you'll often see SIP proxy server for various reasons. They could be used for load balancing. They could be used for centralized call control, stuff like that. SIP proxy server will receive a SIP request from client and forward them on client's behalf to the next device. It will receive SIP messages, forward them to the next SIP server in the network based on predefined configuration. In addition to call routing, SIP proxy server also provide functions such as authentication, authorization, network access control, routing reliable request retransmission, and security. Now, that is a SIP proxy server, which is a dedicated server. Then you have redirect server. A redirect server provides client with the information about the next hop, the hop the message should take, and then client contact the next hop server and user agent directly. The register server, which processes a request from user agent client for registration of their current location, and the register server are often co-located with either the proxy or the redirect server. Now, SIP process is very simple. It's an ASCII-based protocol, so a lot of things are quite familiar to a lot of developers or even end users when they look at the SIP messages. It provides recording, request, and response to establish communication among the various components in the SIP network. Now, users in a SIP network will be given its unique SIP addresses. Now, the address may look like very similar to email address, but of course that is not an email address. It could be like, for example, fcon@voicebootcamp.com, or it could be 1416-839-1717 at voicebootcamp.com. So the user ID could be either a username or it could be E.164 address. The gateway can either be a domain with or without the host name or specific internet IP addresses. The E.164 address happens to be a fully qualified telephone number that is basically controlled by the public switch network. The users will register with the register server using their assigned SIP addresses. For example, your Skype, when you log into Skype username, that is your user ID, like for example, fcon@skype.com. The register server will provide this information to a location server upon request. So location server will query all the register server for, let's say, fcon, and whichever register server say, well, yeah, fcon is registered to this particular server, it will then provide that information to the location server so that proxy server can route the call to the appropriate location. Because the user happens to move between the systems, sometimes it may, an end user may end up registering to multiple devices. So the location server can be used to dynamically register the user to a specific SIP server. A location server can use one or more protocols such as Finger, Whois, or LDAP to locate the end user, kind of like a pinging the username. Now, because the end user can be logged in at more than one station, like your iPhone or your smart Android phone and your desktop at the same time, and location server can sometimes have inaccurate information. So it might return more than one address for the end user. So for example, if you could be logged in from your desktop, at the same time you could be logged in from your iPhone. So you are in two different locations. So sometimes the information could be inaccurate. If the request is coming from a SIP proxy server, the proxy server will proxy server tries each of the return address until it locates the end user. So it might end up dialing this device and that device, and ultimately whichever is for example is going to respond is going to answer the call. If the request is coming through a redirect server, the redirect server will forward all the address to the caller in the contact header field of your invitation response. So every SIP messages has a header, and that header contains various information that you can use to take certain action. And one of the header will be contact header, and that contact header contains an address where the redirector will forward all the calls to that particular address. Now, as I said earlier, the SIP is a request and response method application, which is defined in RFC 3261. Various request method will provide various tasks. For example, initially when you pick up a phone and you dial a number, you're initiating an invite message. This is where the user or the service is being invited to participate in a session. Now, every invite message will have an acknowledgement, which is a confirmation that client has received a final response to that invite message. So you invite, which is like dial the phone number, and the other side, the user agent server will respond with an acknowledgement. Now, when it comes to terminating a call or ending a call by the end user, user agent, then you will send a bye message. And the bye message can be sent by any user agent. Then you have a cancel message. Cancel message basically cancel any pending request. Does not terminate the session that has been accepted though. Option queries the capability of the server, which is also keep alive. So for example, if you want to see if the gateway is active or not, so the call manager can send a keep alive, which is often through the option ping, we call it. The register, which registers the user agent with the register server of a domain. Now, in addition to that, you have more SIP request method. You got the info, which send more information. You got prac, which basically to acknowledge a provisional response. We'll talk more about that prac later. Subscribe, if to tell the remote node to look for certain event, like for example, subscribe to KPML event. Notify, which is to respond when an event occurs. So when certain event occurs, you'll notify the requesting party. You have an update, which updates the parameter of a session. You got message, which is basically SIP instant messaging. And then you have refer, to refer one user agent to communicate with another user agent. Now the publish message, which is used to publish an user state information to the presence server. So that's for presence capability. The SIP invite message contains when you do a debug or when you are looking at some sort of traces, you will see a bunch of messages look something like this. Now this is an example of SIP invite message. The very initial packet on the invite message, you will see the word invite followed by SIP protocol, and then you got the address followed by the port number and the SIP version. So this is a typical invite messages. Every SIP messages will contain bunch of headers. Now SIP headers contains various information such as the username, the address, where the call is going to, the caller ID, and whatnot. So SIP user header, for example, in this scenario will be via, from, to, call-id, etc., etc. In a response, when you send a request, and a response will come in from the other end. So let's assume the response is that the user was not found, or the number that you dialed does not exist. So a response will come back with, like for example, 404 not found. So that's an indication that the number that you dialed was not found for whatever reason it is. And of course, it will tell you where the call came from, where the call was going to. So this is an indication. This is an indication of a response method. So request, which is invite, response, which will give you a response to whatever the resulting event was. Now SIP response works pretty much similar to HTTP response. For example, if you have SIP has a various response code. 1XX response code, 2XX, 3XX, 4XX, 5XX, and 6XX. So when you look at 1XX, for example, if you see the number 100, that means you are ringing the phone. You're trying to ring the phone. You're trying the party. You're trying to dial the number. 180 meaning that a phone is ringing. 183, the session is in progress. So that's an indication that this is informational information. Then you have 2XXX, which is basically success message. Action that was successfully received, understood, or accepted. So for example, if you receive a 200 okay, that means that the other person has acknowledgement successfully. Then you have 202 acceptable. So the message was accepted for whatever whatever the message was. Now 300, which is something to do with the redirection, where SIP element needs to be contacted in order to complete a request. 300 means multiple choices were given. 301 means the number has been permanently moved to different location. 302 means is a temporary move. Number has been moved temporarily. So anytime you see a SIP messages with 300, that's an indication that this is something to do with the redirecting server. Now 400 is a client error. Now this is an error where initiated by the client side. So for example, you dial a number, the number doesn't exist. Or the number was not found, or the user was busy. So if you see 404, that means you're not you're unauthorized to dial the number. 401, 404 was not found. Very similar to your HTTP. Very similar to HTTP. 500 errors, meaning the server side errors. That is something to do with server failure. Now that could be either the server blocked the connection, or server process is not running, the port number is not correct, the security is not correct. Many reasons. 503 is called service unavailable. So that's an indication that the server did not or could not complete the call. 600 or 6XX is a global failure. Request is invalid at any server, meaning that the number is busy everywhere. And or 603, which was mean the number was declined for whatever reason. So it is important for you to have certain you don't have to memorize everything. You don't have to memorize every one of these error messages, but knowing what 100, 200, 300 series does, it helps you troubleshoot the problem. For example, if I see a number with a 400, that's an indication it's a client error. So I need to know where I should be able to, based on that information, know that this is a problem on either the number or the end devices. A basic SIP call, for example, establish a call between a phone. Phone will initiate an invite message to the call manager, for example. Call manager will respond with acknowledgement. Now that 200 means it's successful. So that's an indication of success message. Of course, the phone will say, yes, I accept or I acknowledge your acknowledgement by sending another acknowledgement. At that moment, an RTP session will be established, and then your conversation will start. Now, at some point, the user is going to hang up, so you can the call manager will send a bye message, and the IP phone will then send an acknowledgement saying, okay, I'm ready to hang up as well. Now, if you have a proxy server involved, or something called v2.0, where you have a proxy in between, you got SIP IP phone 1 initiating invite to the proxy, in this case call manager. Call manager will send another invite message to the final destination on behalf of the client. So this is kind of like a when proxy is involved, the endpoint, they do not communicate with each other directly for the signaling part. However, when the RTP is ready to be established, RTP is going to be between the phone 1 and the cube device itself. So all signal, whenever v2.0 is involved or proxy is involved, the signaling is never directly between the end devices, but the RTP is always between the end devices. Now this is an example when you have more advanced, more additional devices, in between. So you can see one proxy here, or a cube device. In that case, all signaling will be local to between the two devices. Okay, so you will never have a signal between phone 1 all the way to SBC service provider. That's not going to happen. However, look at this. Look at the RTP session. RTP will be always between phone 1 and the final destination. All right, so that's pretty much the overview about SIP. Like I said, SIP is a session initiation protocol designed by IETF. It is based on ASCII, and it supports a lot of familiarization with existing protocols such as HTTP, OK, SMTP, DNS. SIP use offer and response, or in request and response type of messages. So that's it. Thank you for watching this video chapter, and I will see you in chapter 2.